Hello and welcome to the final part of this separations journey that we have been going on. And as you can see on the left in part D, this is what we're going to be doing. First, we're going to be deriving the relationship between vapor and liquid compositions for a binary mixture of constant relative volatility. And then we will also be creating arrays in Python. And then we will calculate the average volatility by using that equation there that you can see, and we will compare this plot generated. So without further ado, let's get into it. So first, I got rid of the Colab view for now because I'm going to be typing or writing for a little bit. So first, our general equations are as follows. We will have x1 equals k1 x1, and then also y1 equals k1 y1. So from these equations, I fixed this. This is k2 x2, not k1 y1. So we will have the equation 1 minus y1 equals k2 times 1 minus x1. From here, we will do some dividing, in which we will get y1 over 1 minus y1 equals k2 over k1 times x1 over 1 minus x1. And now, one thing to remember is that the symbol alpha, which is equal to volatility, is equal to k2 over k1. So this k1 over k2 is going to be substituted in by alpha to get y1 over 1 minus y1 equals alpha of x1 over 1 minus x1. From there, we're going to take this and multiply it over here, and then distribute out that alpha. So from here, we will get the value y1 equals alpha times x1 times 1 minus y1 over 1 minus x1. So let's distribute this out, which equals y1 equals alpha x1 minus alpha x1 y1 all over 1 minus x1. And then finally, we're going to multiply this over to the other side. So you get 1 minus x1 times y1 alpha x1 minus alpha x1 y1, which then equals y1 minus x1 y1 equals alpha x1 minus alpha x1 y1. And as you can see, these are actually the exact same things on the left and right side, except this alpha has been distributed out to everything. So you could also look at it as y minus x1 y1 equals alpha times x1 minus x1 y1. You can look at them either ways, but I prefer to look at it this way because I just think it's more satisfying to look at saying, okay, so it's the same equation, but I'm just multiplying that right side by alpha, and that's going to be the difference here. But we will need a little bit more than just this highlighted section. So we are actually going to narrow this down to just the complete y1 value, which after some algebra will get you to y1 equals alpha x1 over 1 minus x1 plus alpha x1. And this is the equation that we are going to use in Google Colabs to help us make this plot. All right, as you can see, I've added back in our Google Colab. And so pretty much what I'm going to do here is I'm going to code in this equation. It's going to spit out a value. It's going to spit out a value, and then we are going to plot that value within this equation above. So let's add our lines below. And the way that we're going to get this is we're going to make an array, but these arrays are going to actually take out the first column. So our first, we'll do y1 equals np.array, which is going to be y1s bracket 1, and then this is that minus 1 will be actually getting rid of the first column, the first number in the first column. And then we want to do the same thing with x1, which that is typed out completely correct. All we have to do is add our bracket in our thing. And then the final step will be taking an average of all of these values. So you want to take the average, which is going to be y1 times 1 minus x1 divided by 1 minus y1 divided by x1. And let us see if that runs correctly. So now we have our value of 2.49. And what we're going to do is take this value and we are going to actually input it above here. And also, I remember saying earlier, I want to make this a line and not just markers. So we'll first change this to lines, and then we'll run all. Okay, now it's an actual line. I like that better. You can do whatever you want, but that's how I'm going to do it. So now, let's go up into this, and here we are going to have to add a alpha value, which we found to be 2.49. And then we are going to have to add the actual line that we just created. So we'll do fig.add_scatter, which will do x equals x1s, y equals alpha times x1s divided by and then again, remember your mode. I like lines. I think it looks better. Name equals constant. And now let's run the. Actually, I'm sorry. We're gonna actually have to need to update the lines on this to make sure that everything fits correctly. Fig.update. That looks good. And then the last thing is show legend equals false, because we don't really need it in there. We know what we're looking at. Ooh. X is not defined. What? Oh, I see. We have a minus here. Oh, it should be that. Except all and run. Yeah, we had a minus instead of let's make this markers, because they're overlapping. That obviously we want them to overlap. That is what the point is. But we want to kind of see both at the same time. You can leave. That'd be good. Okay, perfect. So, no. What did I just do? Oh, we're good. Okay. So as you can see, the blue line is what we graphed originally, and then this constant alpha that you can see marked out in this neon green, that is saying that we calculated it correctly because it is following the curve of the graph that we calculated originally. So thank you for another successful video. I hope you enjoyed, and let me know if you have any feedback. Thank you.